Hello friends, my name is Tushar and today I'm going to talk about traveling salesman problem using Karp algorithm, which is basically a dynamic programming solution. So what is a traveling salesman problem? Let's say we have a graph like this with weights on the edges. The idea is to find the minimum weight route which starts from a vertex and then travels every other vertex exactly once and then ends at this start vertex. So traveling salesman problem is basically finding a minimum weight Hamiltonian circuit in the graph. Traveling salesman problem has many applications, but it is also an NP hard problem. So a brute force way to solve traveling salesman problem would be to generate all possible permutations of these vertices and see which permutation gives you the minimum weight. But the problem is the time complexity for that algorithm will be n factorial. So this algorithm using dynamic programming solves it in exponential time, which although bad is much better than a factorial time algorithm. So next, let's try to understand this algorithm with the help of an example. Here I'm representing my graph as a distance matrix. So for example, cost of going from 0 to 1 is 1 and the cost of going from 0 to 2 is 15 and so on. Also notice it's an asymmetric graph. So for example, the cost of going from 1 to 2 is 7, which is not same as the cost of going from 2 to 1, which is 6. Example of asymmetric graph is flight tickets. For example, cost of flying from city 1 to city 2 might not be same as cost of flying back from city 2 to city 1. Also, if there is no path, if no path exists between a vertex to another vertex, then in this distance matrix we can put a really big number which will prevent that edge to be picked in the traveling salesman route. So now what we're going to do is we're going to have a start vertex 0. So basically we'll start our tour from vertex 0, visit all other vertices and then come back to 0, and this tour should have minimum cost. So the first thing we're going to do is excluding 0. So take remaining of the vertices, so 1, 2 and 3, and then generate all possible subsets. So the possible subsets would be an empty set 1, 2, 3, 1, 2, 2, 3, 1, 3 and then 1, 2, 3. After we are done generating this, we are going to fill up some data, some information in this section here. And to save time, I have written all this beforehand, and we'll see how I'm going to put the data, or how I'm going to put the values here. So the idea is to pick one subset at a time and then go through every vertex in this graph except the start vertex and the vertices in that subset and try to find what is the minimum cost to reach that vertex from start vertex and going through all the vertices in the subset. So one empty set here. So first we're going to pick an empty set. So one empty set here, we are trying to find what is the minimum cost to reach 1 from our start vertex 0 going via this empty set. So since there are no vertices in the empty set, this value is basically the cost to reach 1 via 0. So which is 0 to 1, so 1. And here we are going to indicate that we are reaching 1 from 0. So this parent will be useful in finally building the traveling salesman tour. So now 2 an empty set. So what is the minimum cost to reach 2 via this empty set from start vertex 0? So basically the cost of 0 to 2, so cost of 0 to 2 is 15. Again, this value will be, parent will be 0, indicating that we are reaching 2 from 0. 3 empty set will be cost of 0 to 3, which is 6, and this value will be 0. So let's come to this guy. So we are done traveling, so we are done traversing all the vertices for empty set. So empty set is done. So then we are going to pick the next subset. So the next subset is 1. So we are going to skip 1 because it's already in the subset, so we're going to start from 2. So what is the minimum cost to reach 2 from 0 going via 1? So we already know what is the minimum cost to reach 1 from 0, which is this value. So 1 infinity, 1 empty set plus whatever is the value to reach 2 from 1, which is 1, 2. So 1 to 2 is 7. Whatever is the value to reach 2 from 1, so which is 7. So this value here is 1, So 1 plus 7 is 8. And here we are going to indicate that we are reaching 2 via 1. So next, 3 to 1 is, what is the minimum cost to reach 3 from 0 via 1? So this value again will be 1 and empty set plus whatever it takes to reach 3 from 1. So that is 1, 3, which is 3. So this value is 4. And here we are reaching from 1. So now we're done doing all the vertices for subset 1. So we're going to pick the next subset 2. So here we're trying to find what is the minimum cost to reach 1 going via all the vertices in this subset from start vertex 0. So we already know what it takes to reach 2 from 0, which is 2 empty sets, so 15, plus whatever it costs to reach 1 from 2, so that is 2, 1. So 2, 1 is 6. So this value is 21. And we are indicating we are reaching here from 2. Similarly, 3, 2 will be whatever it takes to reach 2 from 0, which is 15, plus 2 to 3. So 2, 3 is 12. So this is 27. And again we are reaching 3 via 2. Finally, so we are done doing all the vertices for subset 2. So then we are going to pick subset 3. So what is the minimum to reach 1 from 0 via 3? So we already know what it takes to reach 3 from 1, which is 3 empty set, which is 6, plus whatever it takes to reach 1 from 3, so that is 3, 1, so that's 4. So this value is 10, and we are indicating that we are reaching 1 from 3. So this is 3. And then 2 to 3, so minimum it takes to reach 3 from 0 is 6, which is this value, plus whatever it takes to reach 2 from 3, so 3, 2. So 3, 2 is 8. So this value is 14. And we are reaching here from 3. So let's continue to fill rest of the values. So next is 3, subset 1, 2 and 0. So basically trying to find what is the minimum cost to reach 3 going via vertices 1, 2 from start vertex 0. So there are two options here. The vertex right before 3 could be 1, or the vertex right before 3 could be 2. If the vertex right before 3 is 1, in that case the minimum cost we get is whatever it takes to reach 3 from 1, so that is 1, 3, so that is 1, 3, which is 3, plus whatever it takes to reach 1 from vertex 0 with subset 2. So that's this value. Whatever it takes to reach 1 from 0 with subset 2, so that's 21. So minimum of this value, or if you reach 3 from vertex 2, so the vertex right before, if the vertex right before 3 was 2, then 2, 3, so 2, 3 is 12, plus whatever it takes to reach 2 from 0 going via vertex 1, so that value is this. So that's 8. So minimum of these two is 20. So this value will be 20, and we are getting this value when the vertex right before 3 is 2. So we'll say that 3's parent will be 2. Next, let's try to find for 2, 3. So we are trying to find the minimum it takes to reach 1 going via both the vertices 2, 3 from start vertex 0. So 1, so if the vertex right before 1 is 2, in that case the value we get is whatever it takes to reach 2 from 1, so 2, 1, so 6, plus whatever it takes to reach 2 from 0 going via 3, so that value is this, so 14, or if the vertex right before 1 was 3, So the distance from 3 to 1, so distance from 3 to 1 is 4, plus whatever it takes to reach 3 via 2 from 0, so that is this value, so 27. So in this case the minimum value is again 20. And we are indicating that we are reaching 1 from 2. So reaching 1 from 2 will give you this value 20. Finally, let's look for this 2, 1, 3. So basically trying to reach 2 from both vertices 1, 3 starting with vertex 0. So if the vertex right before 2 was 1, so the minimum value we get is, distance from 1 to 2, so distance of 1 to 2 is 7, plus whatever it takes to reach 1 from 0 going via 3, so that value should be here 10, so this is 10. Or if the vertex right before 2 was 3, so the distance from 3 to 2, distance from 3 to 2 is 8, plus whatever it takes to reach 3 via 0 from 1, so that is 4. And the minimum of these two is 12. So here I am going to indicate that we are reaching 2 from 3. So once we are doing all this here will give us a final answer. So what is this doing? We are saying is, what is the minimum cost to reach 0? Going through all the vertices 1, 2 and 3, starting with the vertex 0. So we are ending with the vertex 0, we are starting with the vertex 0 and going through all the other vertices. So this is our traveling salesman's route. This is our traveling salesman's tour. So let's see what are the possibilities there. So we are trying to find the minimum of, so we are trying to find the minimum of 3 possibilities. One is if 1 was the vertex right before 0, or 2 was the vertex right before 0, or 3 was the vertex right before 0. If 1 was the vertex right before 0, in that case we get the cost of going from 0 to 1, going from 1 to 0. So 1 to 0 is 2, plus whatever it takes to reach 1 from 0 going via vertices 2, 3. So that value is right here. The value to reach 1 going via vertices 2, 3 from 0. So that's 20. If the vertex right before 0 is 2, then the cost to reach from 2 to 0, so 2 to 0 is 9, plus whatever it takes to reach 2 from 0 going via vertex 1, 3. So that value is right here. 12 is the minimum value to reach 2 going via vertices 1, 3 starting with start vertex 0, so 12. Or if the vertex right before 0 is 3, so the cost of 3 to 0 is 10, plus whatever is the minimum value to reach 3 from start vertex 0 going via 1, 2. So that value is 20. So the minimum of these 3 is 21. And we are reaching here from 2. So 21 is the minimum cost Hamiltonian circuit, or is the cost of our traveling salesman's problem. So let's try to recreate the tour. So our last vertex is 0. And how do we reach 0? We reach 0 from 2. So the vertex right before 0 is 2. Now the question is, how do we reach 2? So to see how do we reach 2, we see where is this coming from. So we picked 2 here, it means that we have to reach 2 via 1, 3 from 0. So that we reach from 3. So the vertex right before this is 3. So then we are going to see where this 3 is coming from. So to find that, we go to how do we reach 3 from 1 via 0? So that is this value, this guy. So 3 via 1 from 0. So the vertex before this is 1. And finally, where is 1 coming from? So 1 is coming from 0. So 0, 1, 3, 2, 0 is our traveling salesman store. Let's quickly confirm that the cost of this is same as 21. So 0 to 1, 0 to 1 is 1 plus 1 to 3 is 3 plus 3 to 2 is 8 plus 2 to 0 is 2 to 0 is 9. So this is 12 plus 9, 21, which was the cost of our tour. So the time complexity is exponential, so there are exponential number of subsets. So O of 2 raised to n, and for each subset we are going through every vertex, and while going through every vertex we are checking what should be the vertex right before that vertex. So basically we are doing n squared work. So time complexity is 2 raised to n into n squared, and the space complexity also will be same. So next, let's look at the code for this algorithm. The main function here is min cost. It takes in the distance matrix as we discussed before in the video, and it returns the cost of the traveling salesman's route. First, we're going to declare two maps here, which are going to be storing intermediate values. This map is a map from index to integer. Let's look at this class index. Class index has the current vertex and a set vertex set. So what this map is storing is the cost to reach the current vertex from the start vertex, going through all the vertices in the vertex set, and this parent is storing the vertex right before the current vertex in the vertex set, which gives the minimum cost. Then we are going to generate all the combinations except the start vertex. Start vertex in this case is 0, so we are going to generate all the combinations for rest of the vertex, so which is an empty set 1 2 3 1 2 2 3 and 1 3. And then we are going to iterate through all these subsets one by one. So we take one subset at a time, and then for that subset we are going to iterate through all the vertices starting from vertex 1. So we're going to skip the start vertex, which is 0, and start from vertex 1. If the set contains this current vertex, then we are going to ignore it. Otherwise we are going to create this index which is based on the current vertex and set. Our min cost will be infinity and min previous vertex will be 0. And then I'm going to copy this set into a copy set, because Java won't let you update a set while iterating through it. It throws concurrent modification exception, which is why I'm copying the set into the copy set. Then I'm going to iterate through one element at a time in the set and select each of them to be the previous vertex, basically the vertex right before the current vertex. And then we're going to see which one of them gives the minimum cost. So our cost will be the distance of previous vertex from the current vertex plus whatever it takes to reach the previous vertex and going through all the other vertices in the vertex set from the start vertex. So whichever cost gives us the minimum cost becomes our minimum cost, and whichever vertex gives that value is min priv vertex. Also, if the set size is 1, basically if the subset is an empty set, in this case we won't go into this for loop, and our minimum cost in that case will be distance of that current vertex from 0. And then we are going to put this into this min cost. So basically we're going to put index and the min cost, and in the parent map we're going to put the index and the min priv vertex as we found here. After we are done doing this, we finally need to finish our traveling salesman tour. So we're trying to find the cost to reach 0 going through all the vertices 1 2 3 and starting with vertex 0. So to find that, we create a set consisting of 1 2 3, and then we go through each of them one by one and see which one gives the minimum cost. So the cost will be distance of k to 0 plus whatever it takes to reach k from 0 going through all the other vertices, and whatever cost we get is the minimum cost. So this minimum is our minimum cost of traveling salesman's tour. Also, you can print the tour here, and to do that we just go through this parent, and we start from 0, and we keep getting their parent one by one, and keep putting them in the stack. And when the parent becomes null, we break out of this while loop and print the elements of the stack. Let me quickly run this code for you. So As expected, the minimum cost is 21 and the TOR is 01320. So this is all I have to talk about traveling salesman's problem. The link to this code is in the description section of the video. Please like this video, share this video, comment on this video, check out my Facebook page and check out my GitHub link. Thanks again for watching this video.